Okay, uh, good morning. We are going to start. Just wanted to make sure the screen is visible to everyone.
Yes, sir.
And the audio is clear as well.
Yes, sir.
Great, thank you. Thank you very much. Okay. So I'm just going to do a very quick summary of what we did last time. Last time we started talking about random variables. Okay. So we talked about random variables. And random variable is just a mapping from the outcomes to the number line. ठीक है? हर outcome के corresponding आप कहते हैं कि एक number है. हर outcome map करती है एक number के ऊपर. So the values that you get, they belong to a random variable. But the values only do not make up the random variable. We also need something else, is the probability with which those values are taken. So random variable will be characterized, a random variable x will be characterized by values it can take, the values it can take, x values that it can take. So random variable x, capital X, is characterized by the values it can take, small x, okay, and also the corresponding probabilities. This information together is called the probability mass function. K, capital X, which is the random variable, वो क्या possible values ले सकता है? And what is the probability for each of those values? What is the corresponding probability for each of those values? That is called the probability mass function. Probability mass function. We also defined Pxx as the probability. This is the notation that we had used, is the probability that capital X takes a value, some constant value small x. This is your P and F. This is your P. We had also defined the CDF, and the CDF is the function capital F subscript capital X of small x is equal to the probability that capital X takes a value less than equal to. It's very important that you have an equal to here, small x. Okay. And then we defined the mean value or expected value of a random variable. The expected value of the random variable was these x values multiplied with the corresponding probabilities and summed all together. So this would be really equal to summed over all small x, the value x multiplied by the corresponding probability, which is Pxx. This is how we define the expected value. Now, we also did a couple of examples. Today, I'm going to talk about the variance, and for that, I'm going to define moments. What is a moment? The moments of the random variables. So we call expected value of x power n as the nth moment, of x. So by this token, expected value of x power 1, this is simply equal to e to x. This is expected value or mean value. So we notice that the mean value is exactly the same as the first moment. Is the first moment of x is the mean value, or the expected value is the first moment of x. What about expected value of x squared? This is not variance. This is not variance. This is the second moment. This is the second moment. This is the second moment. Now, we can also calculate the moment around something. So, expected value of x power minus a power 1 is the first moment with reference to a. A is a constant. या इसको कहते हैं first moment around a. Now, expected value of x minus a whole square, this is your second moment around a. Now, notice that x is a random variable, but ex is a constant. ये एक constant है. Expected value of x, this would be a constant. कि probabilities को और values को multiply कर रहे हैं और सबको add up कर रहे हैं, you will get a constant number. You will get a constant number. So I can define something कि a को जो है मैं fix कर देता हूँ expected value of x के बराबर. A is that constant. If a is that constant, this guy is second moment. This guy is second moment around ex. This is the second moment around expected value of x. And this is defined as the variance. This is called as the variance. Usko variance. So we define the variance of x as the second moment around expected value of x. इसको थोड़ा ओपन करें, स्क्वायर को ओपन करें और एक्सपेक्टेड वैल्यू को जो है वो अंदर लेके जाएं and then calculate do some manipulation, you will end up getting expected value of x square minus expected value of x whole square. Yeah, now very important to realize what these two terms are. ये पहली वाली जो टर्म है ये एवरेज वैल्यू है x स्क्वायर की. एवरेज वैल्यू है x स्क्वायर की. What that means is कि you take x and take square of each of the value. Take the square of each of the value and then take the mean and take the mean by multiplying the square of the value with the corresponding probability and then summing all those up. This guy is simply the mean value uska square kar diya. Mean value ka square kar diya. Okay. Now mean and variance of linear function ax plus b. Mean and variance of linear function ax plus b in terms of the mean and variance of x. In terms of mean of x and variance of x. So let me define y to be equal to ax plus b. I am interested in finding the mean of y in terms of mean of x. I'm also interested in finding the variance of y in terms of variance of x. Now, before we proceed, let's ask a simple question. Let's say on quiz 2, all the students, they got some marks. If we give 5 extra points to everyone, what do you think would happen to the class mean? What would happen to the class mean? Answers in the chat window. Quiz 2 में सबके grades आए हैं और हर एक को मैंने 5 नंबर extra दे दिए हैं. तो what would be the new class mean? Class का mean change हो जाएगा obviously. Class का mean कैसे change हो जाएगा? Mean would become 5 higher. 5 it would be increased by 5. अगर हर एक को 5 marks extra दे दिए, so the mean will increase by 5. लेट्स से कि अगर हर एक को 5 मार्क्स एक्स्ट्रा दे दें, हर एक को 5 मार्क्स एक्स्ट्रा दे दें, what do you think will happen to the variance? If everyone gets 5 extra marks, what would happen to the variance? Nothing. It will remain the same. Why? The variance qualitatively or intuitively is basically how far you move away, you tend to move away from the mean. अगर आपका random variable x mean के हमेशा पास ही रहता है तो x minus expected value of x ये zero हो जाएगा. If your random variable is always taking the value expected value of x, then there is no variance. The moment that x moves far away from expected value of x, the moment that x moves far away from the expected value of x, you will get the variance. So let me ask you this question. Let's say you have two numbers, 49 and 51. What is the mean? Answers in the chat window. What is the mean? Answers in the chat window. Mean of 49 and 51. Well, mean of 49 and 51 is 50, of course. What about mean of 70 and 30? Mean of 70 and 30. This is also 50. दोनों को ऐड करें, 2 से डिवाइड करें. This is also 50. दोनों सेट्स का मीन 50 है. ठीक है. Now think about कि let's say you have a random variable which takes value 49 with probability 1/2 and 51 with probability 1/2. ठीक है. You have one random variable x1. You have another random variable x2 which takes value 70 with probability 1/2 and takes value 30 with also with probability 1/2. क्या लगता है हमें किसकी वेरिएंस बड़ी होगी? किसकी वेरिएंस बड़ी होगी, x1 और x2? Who will have the larger variance? Who will have the larger variance? Which of these two variables will have the larger variance, x1 or x2? Well, x2 will have the larger variance. And the intuitive explanation of that is if variance measures the tendency of x to move away from expected value of x. Expected value of x से कितना दूर, offset उसका कितना होता है, that defines the variance. अगर offset कम होगा, जो x1 के केस में कि 51 और 49, well, they are not exactly the mean, but they are very close to the mean. The variance is very small. 70 and 30, दोनों इसके केस में भी mean आपका 50 है, but 70 and 30 they are far away from the mean. So in this case, the tendency of the random variable to move away from the mean value would be higher. So variance आपको ये बताती है कि how far the values move away from the mean. तो जो हमारी जो क्लास के अंदर मार्क्स की डिस्ट्रीब्यूशन होती है, if I plot that distribution, if the distribution is thin, everyone got 18 marks, the variance is 0. Standard deviation will be 0. Standard deviation is nothing but the square root of the variance. Okay? So if everyone gets the same marks, there is no standard deviation. If the distribution is fat, if the distribution is fat, इसका मतलब है मीन के इर्द गिर्द जो है वो फैले हुए हैं स्कोर्स ना, कुछ 2, 3, 4, 5 मार्क्स हैं, कुछ 27, 28, 29, 30 मार्क्स हैं. Lots and lots of variation. You will have a lot of variance. So variance is really a measure of variation, mathematical measure of variation. So let's define y is equal to ax plus b. I am interested in finding the variance and mean of y. Now, what we also had learned last time is a function of a random variable, g of x, is a function of random variable x. G of x itself is a random variable. If it is a random variable, you should be able to find the expected value of g of x. And we had an expression for that, And the expression for that was summed over all x, g of x, p x x. And we had an example last time. ये भी हमने cover की थी, जिसमें हम expected value of g, expected value of a function of a random variable मालूम करते थे. Now, if you look at it, y is really a function of x. Y is really a function of x. So finding the expected value of y, simply boils down to finding the expected value of a function of x. Expected value of a function of x. और ये कैसे होगी? ये ऐसे होगी, summation upon x a times small x plus b into p x x. ये मैंने यहां पर क्या लिख दिया? ये चीज, this is g of small x. This is your g of capital X. Now, right hand side can be simplified. Summation is linear. So this would turn out to be expected value of summation over all x. A is a constant, will come out here, and you will have pxx, plus b is constant, will come out here, and you will have pxx. And what is this? This guy here is expected value of x, plus what is this guy? This guy is just b. Why? Because the summation of the probability mass function is 1. Probability mass function always sums up to 1. So you can see that expected value of y for the linear function is a times expected value of x plus b. अगर ये स्क्वायर होता तो मैं फिर ये नहीं कह सकता. Now, we are also interested in variance of y, which is the variance of ax plus b. कैसे मालूम करेंगे? Variance of y is nothing but expected value of y minus expected value of y, the second moment of y around its mean. The second moment of y around its mean. Okay? So values put करते हैं. Expected value of y is ax plus b, okay, minus expected value of y is a times expected value of x minus b whole square. And these two guys here cancel out. And then a square comes out. And you are left with x minus expected value of x whole square. एक बार निकाल दिया आपने square का. So what is this guy? This is simply a square variance of x. So y bars, this is the variance of ax plus b. Variance of ax plus b. भूल जाए अभी ये को, हम ये कह रहे हैं कि जो चीज आप ऐड कर रहे हैं उसका वेरिएंस की सेहत पे फर्क नहीं पड़ता. And this is exactly the same question that I asked earlier. If we give 5 points to every student, if we give 5 constant points to every student, what happens to the variance? It does not change. Okay? In this case, we are not just adding some scores, but we are also multiplying x by a factor a. So if this would be just square of a multiplied by variance of x. What would be the standard deviation of y, which is standard deviation of ax plus b? This is simply equal to a times standard deviation of x. Again, b, there is no b here. No b here. So example is in order. So let's say x is a random variable with expected value of x is equal to 3 and variance of x is equal to 2. So I'm asking you to find the mean and variance of 4x plus 7. First of all, the mean of 4x plus 7 is equal to 4 times mean of x plus 7, which is equal to 4 times 3 plus 7, which is 19. What about variance of 4x plus 7? Answers in the chat window. Variance of 4x plus 7. Answers in the chat window. Somebody is saying 32. How many people agree with that or disagree with that? Or neither? Neutral? Okay. Nobody wants to agree or disagree. So, इसकी जो variance है, this would be equal to 4 square into variance of x, which is equal to 16 times 2, which is equal to 32. It's equal to 32. Now I'm going to talk about some popular discrete random variables. Popular discrete random variables. The first one is called a Bernoulli random variable. Bernoulli random variable. So let's say you have two outcomes in an experiment. One is success, the other is a failure. We define a random variable x as taking value 1 if the experiment results in success and 0 if failure. Now it is totally up to us how I define success and how I define failure. So for example, if you toss a coin, you can define success to be getting a head, or you can define success to be getting a tail. You roll a dice, you can define getting a 4 to be success. When you roll a dice, you can also define an odd number to be a success. तो ये हमारे ऊपर है हम success को कैसे define करते हैं. But once you have a success, there is a probability of that success and a probability of the failure. There is only two possibilities from the experiment. So जब success होगी जो मैंने define की है, whenever success happens, my random variable, Bernoulli random variable, takes the value 1. When failure happens, it takes the value 0. Now, what is the PMF? What is the PMF? PMF क्या कहते हैं? PMF में आप सारी values list कर दें और corresponding probabilities list कर दें. ठीक है? Corresponding probabilities list कर दें. ठीक है? Assume करें कि ये success आती है with probability P. With probability P. So what is expected value of x? Expected value of x is takes the value 1 with the probability P, plus takes the value 0 with probability 1 minus P. So this is simply P. The expected value is simply P. The way to calculate the variance of x is equal to expected value of x square minus expected value of x whole square. ये सेकेंड वाली टर्म जो है ये तो हमने पहले ही कैलकुलेट कर ली, एक्सपेक्टेड वैल्यू ऑफ x, तो नो बिग डील. लेट्स कैलकुलेट दिस. In order to calculate expected value of x square, so basically I square x and I will get a new random variable which is x square. X square is a function of x and it's a new random variable, takes a value 1 and takes a value 0 with probability p and 1 minus p. So this will take the value 1 square with probability p plus 0 square with probability 1 minus p, which turns out to be p. So the variance of x would be equal to p minus expected value of x ka whole square, which is p whole square. So this will turn out to be p into 1 minus 2. This is the variance of Bernoulli random variable. So check notes for examples. कुछ इसमें working examples हैं. Take a look at that. Only 2 very small examples. I'm going to move on to the next random variable, next popular random variable, which is called a binomial random variable. Bernoulli random variable क्या था? An experiment has only two possible outcomes and you perform the experiment just once. In the case of binomial random variable, you perform an experiment some number of times. You perform an experiment n number of times. In each performance or in each trial, the probability of success is some number, let's say p. So if that is the case, then binomial random variable is defined as the total number of successes that you can get. Okay. To define this binomial random variable, let x1, x2, dot, 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 up to xn are Bernoulli random variables. Bernoulli random variables. Then we define x1 जो है वो क्या values ले सकता है? 1 or 0. If success, then 1. If failure, then 0. Okay. So x1 takes two values, either 1 or 0. 1 for success, for whatever definition of success I use, and failure otherwise. Same thing with x2, same thing with x3, same thing with xn. Now, if I ask you, okay, what is this quantity? x1 plus x2 plus dot, dot, dot plus xn. What is this showing? What is this quantity? What is this quantity? Well, this is the total number of successes. Total number of successes. क्योंकि देखिए xi जो है वो 0 भी हो सकता है, 1 भी हो सकता है. If all of these are failures, then you will get 0 as the sum. That means you don't have any success. Number of trials आपके n ही रहेंगे. This is not the number of trials. This is number of successes in the trials. This is total number of successes in n trials. And this is the definition of binomial random variable. So we denote it as binomial n comma p. And we say that x has a distribution, ये ऐसे show करते हैं, x has a distribution which is binomial with parameters n and p, which means you perform n trials and p is the probability of success in each trial, then the total number of successes in those n trials is a binomial random variable. So सबसे पहली चीज है इसका PMF find करना. PMF find करते हैं. PMF find करने के लिए what are the possible values x can take? What are the possible values x can take? Answers in the chat window. What are the possible values x can take? 0, 1, 2 all the way up to n. So PMF के लिए मुझे क्या बताना पड़ेगा? I need to tell what is px0, what is px1, what is px2, what is pxn. ये बताना पड़ेगा ना? What is px0? That means you performed n trials, probability of success in each trial. This is the probability of success in each trial. Okay, and then you end up getting 0 successes. कोई भी success नहीं आई. What is this probability? Answers in the chat window. बहुत आसान है. What is the probability? X takes a value 0. That means no successes. पहले trial किया, कोई success नहीं. And कोई success नहीं with probability 1 minus p. दूसरा किया, फिर कोई success नहीं. तीसरा, चौथा, पांचवा, and all of these are failures. So this is 1 minus p power n. What is the probability x takes the value n? ये last वाली term. Answers in the chat window. Quite right. This is P power n. Why? P is the probability of success in each trial, and trials are independent. So the probability of success in each of those trials is P times P times P times P n terms. So this would be P power n. This would be P power n. Okay. What is the probability? X takes a value 1. आपने n ट्रायल की है, उसमें से एक सक्सेस आनी चाहिए. So this would be 1 minus P power n minus 1 and P power 1. But this success can be anywhere. It could be one of those n guys. So this could be n choose 1. N choose 1. Probability that x takes a value 2. I'm asking you the question कि क्या chance है कि दो successes होंगी. आपने n trials की हैं, दो successes होंगी. तो ये सब बता सकते हैं कि 1 minus P power n minus 2. That means n minus 2 failures हो गए and P power 2 दो successes. But where are those two successes? Those two successes can be anywhere. Okay. How many ways you can pick those? And choose 2 ways. And choose 2 ways. Okay. So example is in order. So 10 repeated rolls of a dice. 10 repeated rolls of a dice. Okay. First part is probability of exactly 1/4. सिर्फ एक ही 4 नजर आता है. What is this probability? Well, पहले तो हमें success define करनी है. What is success? Success is getting exactly 1/4. Okay, and I am interested in getting one success. I am getting exactly one success out of 10 tries. 10 ट्राइयां की हैं, 10 दफा उसको रोल किया. I am interested in the probability of getting exactly 1/4. सिर्फ एक दफा 4 होना है. So 4 को define कर दिया कि success है. So that means there is a probability of success in each trial. And what is that probability? That probability is 1 by 6. Is 1 by 6. So exactly 1/4 means in 10 choose one way, you can pick that 4 to be anywhere. You can pick that successful toss to be anywhere. And then this would be success, which is 1/6 power 1 and 1 minus 1/6 power n minus 1, which is 10 minus 1, which is 9. Okay. Now, second part is probability of at least 1/4. At least 1/4. Who will answer this question? At least 1/4 का मतलब ये है कि या आपके पास एक 4 आ जाए, या 2 आ जाए, या 3 आ जाए, या 4 आ जाए, 5, 6, 7 up to n. At least one आपके पास जरूर है. At least one आपके पास जरूर है. The one way of writing it is कि या आपके पास px1 plus px2 plus px3 plus dot 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 plus pxn. ये सब आनी चाहिए. ये सब आनी चाहिए. So you calculate all of these and you are done. You are done. It turns out that this is a bit cumbersome. इतनी सारी लंबी कैलकुलेशन कौन करे? तो हम इसको ऐसे कर लेते हैं. इसको कहते हैं कि probability of at least 1/4 means 1 minus probability of no 4. कोई 4 नजर ही नहीं आया. ठीक है? This is equal to 1 minus probability x0 px0. Okay. Power. Okay. Now let's try to find the expected value of x and variance of x when x is a binomial with parameters n and p. Now, notice that the Bernoulli random variable had only one parameter, probability of success in the trial. क्योंकि एक ही trial था. Okay. Binomial has two parameters, n and p, number of trials and the probability of success in each trial. And binomial tells you what is the number of successes in the experiment in which you perform n trials. So I'm not going to go with over the proof. The proof is given in the notes, but expected value of x is equal to n times p, and variance of x is equal to n times p 1 minus p. देखें n is equal to 1 के लिए ये एक्सपेक्टेड वैल्यू p बन जाएगी जो बर्नौली की एक्सपेक्टेड वैल्यू है, और वेरिएंस ऑफ x जो है वो n is equal to 1 के लिए वो p into 1 minus p बन जाएगी, which is also the variance of Bernoulli random variable. So becomes Bernoulli for n is equal to 1. Okay. Now, often it is of interest to compute the probabilities of binomial. A trick that is often used computing binomial probabilities. A trick which is often used is probability of x, which is binomial, n comma p. What is the probability? X takes a value k. X take a value k with n choose k, p power k, 1 minus p, n minus k. What is the probability? X takes the value k plus 1. K plus 1. This is n choose k plus 1, p power k plus 1, 1 minus p, n minus k minus 1. N minus k minus 1. Now, we can divide these two equations. एक को दूसरे से divide कर लें. So divide the second one from the first. You will get x is equal to k plus 1 की probability divided by the probability x is equal to k. This will turn out to be, if you solve it, this will turn out to be n minus k divided by k plus 1 multiplied by p over 1 minus p. What this means is, okay, you can take this guy here in the numerator here. इसको move करके मान ले जाते हैं. So let's move it. इसको यहाँ से हमने उठाया और इसको move करके मान लेते हैं. So what we have done here is, now we have found the probability of x taking value k plus 1 by using the probability x takes the value k. इसका मतलब है कि x is equal to 0 के लिए फाइंड कर लें, 1 के लिए इससे फाइंड कर लेंगे, फिर 1 की आ गई तो फिर 2 के लिए इससे फाइंड कर लेंगे, फिर k को इंक्रीज करते जाएं और पिछले वाला k जो है वो उसकी प्रोबेबिलिटी आपको बताती जाएगी कि आगे वाली क्या है. ठीक है. So very easy, computationally efficient way of finding the probabilities of binomial distribution. Okay. Now, binomial random variable is approximated by a random variable called a Poisson random variable. A Poisson random variable. Poisson random variable is approximation to binomial. Approximation to binomial for very large n and very small p, such that
सर एक क्वेश्चन है,
n times p is moderate. जी
हमारे पास प्रोबेबिलिटी फाइंड करने के लिए बायनोमियल प्रोबेबिलिटी इसकी n की वैल्यू भी चाहिए होगी, और अगर n ना गिवन हो हमें,
n ना गिवन है तो आपके पास बाइनोमियल डिस्ट्रीब्यूशन का ही नहीं पता। सो बाइनोमियल डिस्ट्रीब्यूशन कैसे डिफाइन की है, एक बाइनोमियल रैंडम वेरिएबल कैसे डिफाइन किया है कि यू हैव n ट्रायल्स, हाउ मेनी सक्सेसेस। अगर मैं आपको नंबर ऑफ ट्रायल्स ही ना बताऊं तो फिर वो बाइनोमियल नहीं बन सकता। बाइनोमियल बनाने के लिए जरूरी है कि आई फिक्स द नंबर ऑफ ट्रायल्स एंड देन आस्क यू हाउ मेनी सक्सेसेस इन ईच ट्रायल, इन दीस ट्रायल्स। गॉट इट?
ओके ओके
ठीक है, n के बगैर जो है बाइनोमियल बन नहीं सकता, n गिवन होना चाहिए, ठीक है, और यू शुड बी एबल टू फाइंड इट, n फिक्स होना चाहिए। नाउ Poisson random variable is an approximation to binomial for very large n, very small p, such that
Excuse me,
n
sir.
is moderate.
सर
Yes, go ahead.
सर ये ऊपर आपने लिखा है n-k choose k plus 1.
And नहीं, n minus k divided by k plus 1.
हाँ ठीक है.
ठीक है, this is divided by, ये the Benman line लगी। Now, probability that the Poisson random variable x takes a value I is given by e to the minus lambda, lambda power I over I factorial. ये expression किधर से आई? Binomial के केस में, by assuming that n is very large and p is very small, you can prove that कि वो जो हमारे पास binomial probabilities हैं, ये binomial distribution जो है, n choose k, p power k, 1 minus p, 1 minus k, that converges to this. वो इसके equal बन जाती है. And I is equal to 0, 1, 2. Again, this is the number of successes. This is the number of successes that you get. Now, Poisson random variable has a very, very large number of trials. So n is tending to infinity. N is tending to infinity. We can also verify that Poisson is a PMF. कैसे verify करेंगे? Can verify that Poisson, ये वाली जो हमने यहाँ वैल्यू लिख दी है, ये is actually a PMF. Is actually a PMF. कैसे find out करेंगे? Sum I is equal to 0 to infinity e to the minus lambda, lambda power I over I factorial. You will notice that this turns out to be one, not too difficult. इसके अंदर जो है वो टेलर सीरीज लगानी पड़ेगी and then you can easily show it. Example करते हैं. Oops. Let's do an example. So typos on a printed page. Now, appreciate the situation here. On a printed page, you have lots and lots of letters. ठीक है? और बहुत कम typos होते हैं. So typos on a page satisfy that large and small p. Okay, and on average you will get some value of that. Typos on a printed page. So let's say x is given as the typos on a printed page, and this is Poisson with some parameter lambda, and let's say lambda is equal to, in this case lambda is equal to 1 over 2. ये आपको दिया हुआ है. And we will shortly see कि ये 1 over 2 जो है ये mean value के साथ related है. So what is the probability that you pick a page and there is at least one error? This is equal to 1 minus probability of no error. Everyone will agree with that? And 1 minus probability of no error means 1 minus probability your x guy is equal to 0. फिर x का is equal to 0 and when this guy is 0 this is e to the minus lambda power 0 over 0 factorial. ये पूरी की पूरी चीज 1 हो जाती है. So this would be equal to 1 minus e to the minus lambda or 1 minus e to the minus 1 over 2 which turns out to be 0.393.
सर ये लैम्डा क्या चीज है?
ये लैम्डा जो है ये इसका डिस्ट्रीब्यूशन का पैरामीटर है जो एक फिक्स वैल्यू होगी. अभी आपको पता चलता है कि ये लैम्डा है क्या चीज. ये कैरेक्टराइज जो है हम इसको डिस्ट्रीब्यूशन को कर रहे हैं विद लैम्डा एंड लैम्डा इन दिस केस you will see that it turns out to be n times p. Will turn out to be n times p. ये जो हमने कहा है ना कि n very large, p very small, such that n times p is moderate. What is that moderate number? That moderate number is lambda. That moderate number is lambda. Okay. So the probability x is equal to I is given by this. Okay. So now I'm going to find out what is the expected value and variance of x when x is Poisson lambda. So since we said that Poisson is an approximation to binomial for large n and small p, so let's take a look at the mean and variance of binomial. Okay, mean of binomial was n times p and variance of binomial was np times 1 minus p. If p is very small, n is very large, ठीक है, तो n times p जो है वो क्या बनेगा, such that n times p is moderate, वो वही रहेगा, n times p रहेगा जिसको हमने lambda define किया. So that means कि we suspect कि Poisson की जो expected value है वो lambda के बराबर है. Poisson doesn't know anything about n and p. Poisson only knows about lambda, which is the product of n and p. Poisson only knows about it. And what would be the variance of a Poisson random variable? Again, p बहुत छोटा हो तो 1 minus p जो है वो close to 1 होगा, and then you are left with n times p, which is again lambda. So हम ये guess करते हैं कि ये lambda के बराबर होगा. For x, a Poisson lambda random variable. For x, a Poisson lambda random variable. X एक Poisson random variable है जिसका पैरामीटर lambda है, तो expected value of x वो भी lambda होगी, variance जो है वो भी lambda होगी. हमने guess किया, but we can prove that. एक तो सीधा प्रूफ है कि बाइनोमियल को मीन और वेरिएंस लें और उनके मीन और वेरिएंस को आप अप्रोक्सीमेशन डाल दें उसमें कि n is large, p is small, you will get lambda for both of them. ठीक है. So I'm going to talk about our fourth random variable of today. Binomial हो गया. The third one was Poisson. And fourth one is a geometric random variable. देखिए, अब आपको याद कराते हैं कि बर्नौली एक ही ट्रायल करना है, या सक्सेस या फेलियर, ठीक है, एंड द प्रोबेबिलिटी इज p characterizes Bernoulli. p पता चल गया तो Bernoulli random variable का होगा. For binomial you have repeated trials. How many? n trials, and the number of successes in those n trials is a binomial random variable. So binomial distribution is defined by or characterized by two parameters. One is n and the other is probability of success in each trial, which is p. So binomial probabilities will be dependent upon n as well as p. And then we have Poisson, in which n times p को हम lambda कर देते हैं, where lambda is moderate. n is very high, p is very low, but दोनों का product जो है वो moderate है. तो Poisson random variable is also characterized by a single parameter, which is n times p or lambda, which is lambda. So उसकी expected value और variance भी हमने find out, तीनों की हमने find out. Now what is this geometric variable, random variable? ये मिलता जुलता है बाइनोमियल से, बट वेरी वेरी डिफरेंट, वेरी वेरी डिफरेंट, ठीक है। अगेन रिपीटेड ट्रायल्स, बाइनोमियल में भी यही होता था, रिपीटेड ट्रायल्स होता था, लेकिन बाइनोमियल में नंबर ऑफ ट्रायल्स वाज फिक्स्ड। एंड ट्रायल्स होंगे, चाहे सब के सब जीत जाएं, चाहे सब के सब हार जाएं, चाहे कुछ भी मिक्स एंड मैच हो, but n trials were fixed in the case of binomial. For the case of geometric random variable, you repeat the trial, each with probability p of success, and you keep repeating until you see the success. जहां पहली सक्सेस मिलेगी वहां पे फुल स्टॉप आ जाएगा. Now geometric random variable is the total number of trials that you have performed until the first success. Okay. So geometric random variable x is number of trials until first success. Until first success. So if p is the probability, probability of success, each trial, हर trial में p is the probability of success है, then what is the probability that your geometric random variable x takes a value? By the way, what values x can take? Answers in the chat window. x क्या values ले सकते हैं? x is the number of trials until you see the first success. Can x take a value 0? Well, x cannot take a value 0 क्योंकि एक ट्रायल तो करना पड़ेगा ही ना आपको सक्सेस के लिए. So it takes values 1 to infinity. So what is the probability x takes a value 1? Answers in the chat window. Probability x takes the value 1. Is p. What is the probability x takes the value 2? X will take the value 2 when the first guy is a failure and the second guy is a success. And what about probability of x is equal to 7? X is equal to 7. Well, x is equal to 7 means you again win on the last one and the first 6 are failures. इसमें कोई n choose 2 नहीं आ रहा, 6 choose 1 नहीं आ रहा, कोई कुछ नहीं आ रहा. क्यों नहीं आ रहा? Because we have just one success and it is sitting at the end. उससे पहले सारी फेलियर है. अगर उससे पहले सक्सेस आ जाती तो मैं वहीं पे एक्सपेरिमेंट तोड़ देता. I would have stopped the experiment right there when I saw the first success. मुझे और उसके बाद एक्सपेरिमेंट करने की जरूरत नहीं. Now I'm going to ask again, based on this pattern, what do you think would be the probability x takes a value n? What is the probability x takes a value n? Answers in the chat window. So this would be x takes the value n. Well, this would be p into 1 minus p plus 1. और इसको सम अप करें, all these values summed up together, nice geometric series बनेगी, infinite geometric series बनेगी, nice, very easy to sum up. उसको sum up करेंगे and you will get that the sum of all of these guys is equal to 1. And it has to be because this is the PMF. Okay. So एक जो क्वेश्चन ज्योमेट्रिक के बारे में पूछा जाता है वो ये पूछा जाता है कि what is the probability that you need at least 15 trials to get the first success? ये थोड़ा सा डिफरेंट क्वेश्चन है बट रिलेटेड क्वेश्चन, एंड इसका कोई हिंट दिया हुआ है नोट्स में सॉल्व करने के लिए. प्लीज टेक अ लुक एट दैट. Mean and variance of geometry. So expected value of x. Now there is a procedure to solve that. and I'm not going to do that here, it's given in the notes, but, and you may have seen it in the earlier classes as well, that expected value of x, the mean value of x is 1 over p, and it makes perfect sense to me, perfect sense to me. क्यों? ये इक्वेशन क्या बता रही है आपको, जरा इंट्यूशन देते हैं. देखें, p is the probability of success in each trial. P is the probability of success in each trial. If p is very small, you should expect to perform many trials. You should expect to perform many trials. So let's say कि आपने 6 लेकर आना है एक डाइस के ऊपर, 6 लेकर आना है एक डाइस के ऊपर. What is the probability of getting a 6 on a single roll? Is 1 over 6. So the expected value of this geometric random variable until you see the first success, and the success in this case is seeing a 6, the expected number of trials that you have to perform is 1 over 6, which is 6. This makes perfect sense. This makes perfect sense. 1 by 6 उसकी probability आने की. So on average expected value आपके पास इसकी 6 दफा आपको टॉस करना चाहिए. पॉइंट के लिए आपको सिर्फ 2 दफा करना पड़ेगा. If head is a success, then the probability until the number of trials expected until the first success is going to be just 2. 1 over 2, which is 2. So if you keep on decreasing p, अगर probability of success in single trial जो है वो बहुत कम करते जाएंगे, expected value of x proportionally ज़्यादा होती जाएगी, proportionally ज़्यादा. So that's the fine intuition behind it. Now, what about mean and variance? Mean and variance. Mean निकल आया हमारे पास, and then the variance of x is going to be q divided by p square. And what is q? Q is nothing but 1 minus p. So it can also be written as 1 minus p whole divided by p square. Whole divided by p square. Now, there is another random variable which is called the negative binomial random variable. So geometric की extension है. Geometric में you count the number of trials until the first success, and these trials are independent. Don't forget that. So the number of trials until the first success on average is 1 over p. On average, it is 1 over p. अगर मैं आपसे कहूँ कि एक dice roll करना है आपने, and what is the number of trials needed until you see the first 6, तो आप सीधा कहेंगे 1 over 1 by 6, which is 6. Average value उसकी 6 आ जाएगी. If I ask you, what is the expected number of trials needed to get 3 6s? 3 6s, not 3 in a row, to get 3 6s. आपने ट्रायल करने शुरू किए और काउंट करना शुरू कर दिया. पहला 6 आया, ओके, कंटिन्यू. फिर दूसरा 6 आया, ओके, कंटिन्यू. फिर तीसरा 6 आया, and now you stop. What is the expected number of trials until the third success? That is simply, क्योंकि सारे trials independent हैं, तो intuition हमें ये कहती है कि वो 1 over p multiplied by 3, 1 over p which is 6 plus 6 होगा. पहला 6 देखने के लिए on average अगर मुझे 6 times 10 6 बारियों का इंतजार करना पड़ रहा है, तो दूसरे 6 के लिए भी मुझे 6 का इंतजार करना पड़ेगा after the first one. तो तीसरे 6 के लिए I will still need another 6 trials after the second one. So total 6 times 3 or 18 trials. 18 trials. अगर मैं आपसे ये कहता कि keep tossing और dice roll करते जाएं और आपके पास 3 consecutive 6 आते हैं, that is your success. What is the probability? What is the expected value of number of trials until you see the first success? Okay. That would be 1 divided by the probability of success. And what is the probability of success here? The probability of success for 3 consecutive 6s is 1 by 6 into 1 by 6 into 1 by 6. So this is a very small number, 1 over 216. So in order to see 3 consecutive 6s, you should expect to roll 216 times. 216 times. So now I'm going to talk about multiple random variables. एक random variable की तो बात हो गई. I am going to talk about multiple random variables. Simple extension of the concept. Okay. Remember that probability x takes a value x is given by pxx. This is the PMF of a single random variable. PMF of a single random variable. We can similarly define the PMF for multiple random variables. First of all, think about this, that this is an event. This event involves only one single random variable. You can define another random variable, 1, 2, 3, 4, 5, as many random variables as you want on that same sample space, ठीक है? तो मेरा जो इवेंट है वो दो रैंडम वेरिएबल्स पे भी कंसिस्ट कर सकता है, दो से ज्यादा पे भी कर सकता है. So I will give you an example. Say probability that x takes the value x and y takes the value y. So think of it as two events, x taking a value x and y taking a value y. So two events, probability of A and B happening together. Probability of A and B happening together. This is called P x comma y. This is the joint probability mass function of x, capital X and y, capital X and y. Joint probability mass function of capital X and y. Okay. Now, I will give you an example. Example से पहले इस पे जरा गौर करें कि probability of A and B ये हमने कहीं देखी भी है पहले. So this was equal to probability of A, probability of B given A according to the chain rule. So try to apply it here. You will have probability x is equal to x and y is equal to y is equal to probability x takes the value x into the probability that x is equal to x. Sorry. So b. Y is equal to y given x takes the value x. Why can I write this? देखिए ये तो हमने देख लिया पहले कि this is the joint PMF. Probability x is equal to x. This is simply the PMF of x. What is this guy? Any guesses? Answers in the chat window. कोई guess करना चाहेगा ये? तो probability, conditional probability है, नजर आ रही है कि एक event given the other event. What is the probability of one event given the probability of given the other event? तो अगर आपको हमने बता दिया है कि x takes the value x, then what is the probability that y takes the value y? This is called P of y given x. This is called the conditional PMF of y given x. Conditional PMF of y given x is equal to x. Conditional PMF of y given x is equal to x. अगर एक x is equal to 2 दिया हो तो y का कुछ PMF होगा, x is equal to 3 दिया हो तो y का कुछ और PMF होगा. अगर x is equal to 7 दिया हो तो y का PMF कुछ और आ जाएगा. Why? Because the conditional PMF of y depends upon कि वो x क्या है. Sometimes it will happen कि आप x की कोई भी वैल्यू ले लें, the PMF of y given x does not change, which means कि y is a random variable which is independent of x. If given any value of x, the conditional PMF of y given x, if given any value of x is equal to small x, first करें आपको कोई small x value given x is equal to, and small x can be anything. Given x is equal to, the conditional PMF of y given x is equal to x does not change, then y is independent of x. x एक ऐसा random variable है जो y की सेहत पे असर नहीं डालता. These two random variables do not impact each other. If y is independent of x, then x is also independent of y. बिल्कुल उसी तरह जैसे if an event is independent of another event b, then b is also independent of a. B is also independent. In the same way, if y is independent of x, then x is also independent of y. Okay? I'll give you an example. एक example करते हैं. So example is okay, pick three balls from this box जिसके अंदर 3 रेड हैं, 4 वाइट हैं और 5 ब्लैक हैं. Pick 3 balls without replacement, of course, without replacement या simultaneously pick करने या without replacement एक एक करके pick करने, एक ही बात है. So let x is equal to number of red balls that you pick. Y is equal to number of white balls that you pick. What are the possible values x can take? X can take what possible values? Answers in the chat window. What possible values x can take? Answers in the chat window. Number of red balls हैं, 3 balls आपने pick की हैं, x कितनी value ले सकते हैं? X can take value 0, 1, 2, 3. Is this the PMF of x? Yes or no? No, this is not the PMF of x, but it will become PMF of x if I tell you कि ये x की 0 लेने की क्या probability है, 1 लेने की क्या probability है, 2 लेने की क्या probability है, and x takes the value 3. What is the probability of that? If I tell you all 4 probabilities that x takes these 4 values, then it would be the PMF. Okay. What about y? Y is the number of white balls. What values y can take? Y can also take 4 values 0, 1, 2, 3. Also take these 4 values 0, 1, 2, 3. The joint PMF for each value of x, y can take one value. The joint PMF of x, y, of x and y, the joint PMF of x and y written as p x, y, x, y, जो हमने ऊपर लिखा भी है, this is joint PMF p x, y, x, y. This is how you write it. So this is the probability. X takes the value x and y takes the value y. So joint PMF of x and y, the joint PMF of x and y, which is written as pxy, this is the probability. X takes the value x, y takes the value y. So see, x is taking 4 possible values, y is taking 4 possible values. So 4 points here, 4 points here, 4 points here, and 4 points here. How many points? Oops. How many points here? कितने points? Answers in the chat window. What are the different possible values? X and y की combination हमारे पास आ सकती है. X की 0 के लिए y की चारों वैल्यू आएंगी. X की 1 के लिए भी y की चारों वैल्यू आएंगी. 2 के लिए भी चारों वैल्यू आएंगी. 3 के लिए भी चारों वैल्यू आएंगी. So 4 times 4, 16 different possible इसके अंदर आपके पास values आ सकती हैं. So I will need to calculate p x y 0, 0. This is the probability that x takes the value 0 and y takes the value 0. What is this probability? ये बताएं. p x y 0, 1. X takes the value 0, y takes the value 1. ये बताएं. p x y 1, 0. ये बताएं. And so on and so forth. ये पूरी 16 की 16 आप values बताएं. And then this will be your PMF. This will be your PMF. इस PMF को हम ड्रॉ कर देते हैं. इस PMF को हम ड्रॉ कर देते हैं और इस PMF के अंदर x can take value 0, 1, 2 and 3. Y can take value 0, 1, 2, 3. What is the probability? What is the probability that x takes the value 0 and y takes the value 0? एक calculate करते हैं. What is the probability that x takes the value 0 and y takes the value 0? दोनों ही 0 0 आ गए. इसका क्या मतलब है कि आपने 3 बॉल्स पिक की हैं, रेड भी 0 आ गई और व्हाइट भी 0 आ गई. What does that mean? That means that you have picked all the 3 black balls. All the 3 black balls. 3 black balls आपने pick कर ली. So anyone who can give me the answer for pxy 0, 0, which means you pick 3 balls, 0 reds and 0 whites. 0 reds and 0 whites, which means that all 3 are blacks. So this is going to be 5 out of 12 multiplied by 4 out of 11 multiplied by 3 out of 10. Thank you very much. इसने भी लिखा. So this turns out to be 30 divided by 220. 30 divided by 220. You can compute it at home. Now I can fill this table up. Actually 30 नहीं आएगा. Come on, चाहिए. So we 10 divided by 220. So now I can fill this table up, and filling it up, this would be 10 over 220. This would be 40 over 220. This would be 30 over 220. And this would be 4 over 220. What is the probability? What is the probability? X takes the value 3 and y takes the value 3. P, X, Y, 3, 3. मुझे यहाँ पे कुछ लिखना. What is that probability? That probability 3 नहीं हो सकती. So that probability is 0. 3 and 2 ये भी 0 है. 2 and 3 ये भी 0 है. 3 and 1 ये भी 0 है. 1 and 3 ये भी 0 है. And this guy is again 1 over 220, and this guy is 15 over 220, and this guy is 30 over 220, and you will notice that this is 60 over 220. ये सारी कैलकुलेट की जा सकती हैं. 12 over 220 बिल्कुल उसी तरह से कैलकुलेट की जा सकती हैं जैसे ये किसी ने मुझे बताई कैलकुलेट करनी. And then this is 18 over 220, and this will also be 0. 2 और 2 जो है ये भी 0. Now I'm going to do some magic here, and the magic here is p x y इसको सम करते हैं x के ऊपर और सम करते हैं y के ऊपर. The order of summation does not matter. Order of summation does not matter. So देखें यहाँ पे आपको p x y क्या बता रहा है कि the probability x takes this value and y takes this value. और exhaustively आपने पूरी की पूरी values cover कर दी. All the 16 possible आपने combinations इसमें डाल दी हैं. ठीक है. इसके अलावा और कुछ नहीं हो सकता. और इनमें से कोई एक ही होगा. इनमें से कोई एक ही होगा. So this probability summed over all possible values of x, summed over all possible values of y. कोई guess करेगा ये क्या आएगा? This is the sum of joint PMF. जिस तरह एक सिंगल PMF को सम करें तो आंसर आपके पास 1 आता था, तो आपने सारी पॉसिबल वैल्यूज के ऊपर उसको सम कर दिया. Now you have summed over all possible values. This should also be equal to 1. This should also be equal to 1. Okay. So this is your y values and these are your x values. So I'm going to ask you this thing. Okay, अगर मैं ये करता हूँ, if I pick these guys, ये जो मैं सर्कल में डाल रहा हूँ, if I pick these 4 guys and add them up, what is this probability? इन 4 probability number को मैं add कर दूं, तो what is this probability? फिगर देखने से पता चल जाना चाहिए कि ये vertically आपका x जा रहा है और ये horizontally आपका y जा रहा है. X takes value 0, y takes value 0 with 10 by 20. X takes value 0, y takes value 1 with 40 by 220. if I add all of these four guys up, what does this turn out to be? What does this turn out to be? ये क्या चीज? Answers in the chat. This is the probability x takes the value 0. There is no other way x can take the probability, x can take the value 0. देखिए x जो है 0 वैल्यू लेता है, x 0 वैल्यू लेता है, या ये इसके y के 0 के साथ होगा, या y के 1 के साथ होगा, या y के 2 के साथ, या y के 3 के साथ. And this is really px0, px0. इसका मतलब है if I sum over y, pxy, x comma y, then what I really get is pxx. Similarly, if I sum over x, pxy, x comma y, then I will get by of y. ये भी कैसे पता चलता है? ये भी एक एग्जांपल देख लेते हैं. So this example would be, I am going to consider this column here. This column here. इन चारों को ऐड कर देते हैं. Y takes the value 1 in this whole column. X चाहे भले 0 हो, X चाहे 1 हो, X चाहे 2 हो, X चाहे 3 हो. So this is all the probabilities that Y takes the value 1. There is no other probability Y will take the value 1. And these are the only ones Y will take the value 1. उन सबको ऐड कर दें तो probability Y is equal to 1. So X में हमने ऐड कर दिया, X के ऊपर समेशन कर दिया अगर, तो Y का PMF निकल आएगा. Y पे समेशन कर दी तो X का PMF निकल आएगा. These are called, ये हमें पता है कि ये सिंगल रैंडम वेरिएबल के PMF हैं, सिंगल रैंडम वेरिएबल के PMF हैं. इन द कॉन्टेक्स्ट जब मल्टीपल रैंडम वेरिएबल्स के साथ हम खेल रहे हैं, ठीक है, वहां पे जब ज्वाइंट में से हम एक सिंगल को निकालते हैं, इसको हम बोलते हैं मार्जिनल प्रोबेबिलिटी मास फंक्शन, मार्जिनल PMF. So this is marginal PMF of y, this is marginal PMF of x, marginal PMF of y, marginal PMF. So there are a few other examples which are given in the notes. हमने ये notes जो है वो in fact ये joint वाले अभी तक upload नहीं किए हैं. I will upload those sometimes today, and we will stop here. If there are any questions, I will be happy to answer that. Otherwise, we will close the session. कोई क्वेश्चन?
सर इसमें किसी भी ऑफसेट के ऊपर हम समेशन कर लें, फॉर एग्जांपल जिस तरह आपने y इक्वल्स टू 1 पे x को की समेशन की हुई है,
y is equal to 1 पे की है, तो मुझे मेरे पास क्या आ गई? py of 1, probability y is equal to 1. अगर मैं ये इस पे समेशन करूं तो this is the probability y is equal to 3, py3. This is py3. ठीक है?
ओके.
Make sense? कोई और क्वेश्चन? No questions. Okay. So this is very simple multiple random variable का अभी हमने बहुत simple सा start किया है. There will be lot more information about jointly distributed random variables. उनकी expectations calculate करनी, उनकी conditional expectation calculate करनी, and we will talk about that in the next 2-3 weeks. 2-3 हफ्ते में हम वो करेंगे. Before we move on to the material which really should be the sort of new material in this course. अभी तक तो हम ये कुछ revisions ही कर रहे हैं पुराने किसी early course से. Okay. So please make sure that you go over the notes. If you have not looked at the lecture, बाद में join किया किसी ने तो वो please lecture पे YouTube पे डाल देंगे हम, वो वहाँ से देख लें. We will cover all of this in the quiz as well. So you should be able to do the homework, complete the homework with this information. इससे ज़्यादा नहीं चाहिए. Homework के अंदर जो joint के सवाल हैं, there are only a few questions, 3 या 4 questions हैं. Those are pretty simple, very simple. This information के साथ you should easily be able to solve all of those. ठीक है? All right. So we will see you on next Wednesday. Actually on Monday. Stop the share and to close the session now.